And now we can see that we get way more detections on our image here. So now we can actually see that we're detecting all the numbers here in our license plate. Hey guys, welcome to a new video in this computer vision and deep learning tutorial. In this video here, we're going to talk about EasyOCR for character recognition. So we're going to take a couple of different kind of images, and then we want to do character recognition so we can actually like detect text and so on in the images. It could actually be like license plates or something like that, or if you just have some text that you want to detect in your image, we can set up EasyOCR really fast and it's really convenient to use. We can just set it up with a couple lines of code, pass our image through the model, and then we'll get the output out with both the confidence score, the bounding box, and also the text that it had recognized in the image. But first of all, remember to join Discord server. I'll link to the description here. You can join the channel, chat about computer vision, deep learning, AI, and so on. You can also become a member of the channel for a small monthly fee. Everything will go to create more and better quality content here on the channel. Also, if you're a member of the channel, I can also help you out in your own projects. If you have some problems, I can help you out, give some guidance and so on if you're a member of the channel. So thank you guys. Also, make sure to hit the subscribe button under the video here. Again, only 10% of you guys are watching these videos here are actually like subscribing. So it will mean a lot for me and the YouTube channel here if you'll go down and hit the subscribe button. And also you will get notifications when I upload new videos about computer vision, deep learning, AI, and so on. So thank you guys. So let's just jump straight into the code here. First of all, we're just going to write the lines of code. It's only a couple of lines that we need to write. So I'll just go over those lines, write them here in this tutorial so you guys can follow through and maybe do it on your own. Again, all the code will be available on my GitHub. But first of all, we need to import, or like we need to install EasyOCR first of all. So we're just going to open up our command prompt or our Anaconda prompt, and then we can actually just pip install EasyOCR. So we can just go in here, pip install EasyOCR, and then we can just hit enter, and it will then install EasyOCR onto our computer. So we can see already my requirements are already satisfied. So I've already installed EasyOCR here on my computer. But it's basically everything we need to do to install these things here that we need in this tutorial if you have OpenCV already. If you don't have OpenCV, again, you can just pip install OpenCV as well. So that will be OpenCV. And if we're using Python as we're doing in this tutorial, it will just be OpenCV Python. So now we have everything we need. Now we can just go inside here and import the modules. So here we're just going to import the first couple of modules. So we just do the standard one. So we're going to import NumPy as NP. And then we also need to import OpenCV because we're going to use OpenCV to actually like read in our images and also display our results later on. So then we're just going to import CV2. And then we also need to import EasyOCR so we can actually use the character recognition model here from that module that we just installed. So now we actually have everything imported here, and we can then set up our reader from our EasyOCR model. So we can just go in here, have a variable called reader, or like an object we call reader, and then we just go inside EasyOCR dot, and then have a module here called reader, or like a method that just basically it just reads in, or like we're basically just passing in some arguments here to the constructor of this class, and then it will just create this instance of our class, which is an object. So here, first of all, we need to have the language list. So we need to specify the languages that we want to detect in our image. And this video here, we're just going to go with EN for the English language. So we only want to detect English text in our images here that we're going to pass through our model. If you also have set up the GPU, we can also see here that the GPU is default equal to true. You can also set it equal to false, and then it will use your CPU to actually like do this processing here on your computer. But again, as default, it is set to true, and we're just going to stick with that for this video because I have a GPU I can run the model on in this video here, so it will speed up the process when we're actually like going to pass our image through that model and detect the characters and the text in our image. So this is the only thing that we need to set up here for our OCR reader. Then we can also go down, we can just pass in our image through it. So we're just going to inside our reader, and then there's a function or like a method called read text. And then we just pass in the path to our image here. It could also be an image that you load in from your webcam and so on. So now when we have set up this reader, we can actually just go down, create a variable for our OCR results. So now we have actually set up our OCR model that can do character recognition. So here we're just going to have a variable where we're going to store our OCR results. We just set that equal to our reader, and then inside our reader we have a method called read text. So we have this read text method where we just pass in our image. We can see the data type here is just any, so we can just pass in any images to this function here. But in this case, we're just specifying a path to our image. So we're just going to the C drive that I have on my computer, and then we're just going to specify the path for this image that I'm going to show you in this tutorial. So I'm just going to type out this path here. So we have this path, my personal path here inside my users, and then I have an image just called image.png. Then we basically have our image. We read in our image, we pass it through our model, and then we store results in this variable. So this is actually just some structure that we can go in and index based on what results do we want to get. So we both get a bounding box, the text that it has detected, both like all the characters, and also a confidence score of like how confident is the model that this is actually like text that is detected, and also the correct text. So here we're just going to print these OCR results just to show you guys like what is going on and what is the output, what is the direct output from this model. So these are the only 2 lines of code that we need to pass in. So here we can see that it is now running this Python script. So first of all, we need to download the model. We can see that it just downloaded up here before I ran this program. But down here at the bottom, we can actually see the output. So I'll just run the program here again, delete this terminal so we can get a more clear output. So here we're just passing our image through our OCR model. It does the detections, and then we just print out the raw results here. So here you can see we get the bounding box as the first index in our variable here, or like we return this object that we can just access. And then we also, so we have this tuple of these different kind of values. So in the first index of our tuple, we have the bounding box of the text that we detected, and then we also have the text that we detected. So we can see in this image we have some text called Python. So we're detecting Python in our image, and then we also need we also have a confidence score here. So in this example, it has a 97% confidence score that this text here that it has detected in the image, or like recognized in the image, is actually like Python. We can also see some other different kind of detections here. So we also have some other images. It also detects some other different kind of characters. It has a G4H4H, and it has a really low confidence score. So this is most likely a false positive, and so on. So we get all these different kind of like we get all these different kind of detections in our image, and we can then filter it based on our threshold, based on our confidence score, which we can set up as a threshold, as I'm also going to show you throughout this video. We can also see that we're detecting computer vision with a 96.6% confidence score, and we can also see here we also detect VS here with a fairly high confidence score. So we only get like around 1 false positive here in this example, and in just a second I'm going to show you the results where we're going to use OpenCV to do image show, so we can actually like show what is going on, draw the bounding box, and also display the text here on our image. But it's just the raw data that we get out from our model after passing our image through it. Again, we can just have like a live video stream with a webcam. I'm going to do another tutorial about that, where we just read in images from a webcam, pass it through this model here, and then do live object or like text recognition or the character recognition. So make sure to subscribe to this channel here, and also hit the bell notification so we get a notification when I upload a new video in this computer vision and deep learning tutorial. It could either be like something else, or like specifically how we can read text and also recognize text in images. So now we have these results here. Now we want to set up the bounding boxes so we can actually like draw our bounding boxes around the text that we're detecting. First of all, we're just going to take the top left corner. So we're just going to take the top left corner. It should be over here, or like the top left corner, and then the bottom right corner, which will be over here on your guys' screen. And then we can actually just pass in that into the rectangle function from OpenCV, and it will draw a rectangle around the text. So we just go inside our OCR results, and then we just go inside the tuple. We're just going to do the indexes. So it will be the serifed index, and the serifed index here again. And then we have the serifed index here as well, because this will be the top left corner. And when we're going to take the bottom left corner, or like the bottom right corner, we're going to take the second index here at the end, because the first index will be the other corner, like the top right corner, and then the left, or like the bottom right corner, or like the bottom left corner will be the fourth element. So we have like some kind of like point, and point when we're actually like talking about our indexes here in our tuple. So these are the different kind of indexes will be our confidence score, and also the text that were detected, as I'm just going to show you here in a second. So we're going to change this variable here to our bottom right corner. We're just going to have this bottom underscore right. So now I have a top left corner and a bottom right corner, and now we actually have all the information for our bounding box. Then we can have another variable here for our text, which will just be equal to our OCR results again. So I have our OCR results, and then we're going to take the serifed element, because this is the first detection. And then we're going to inside just take the first element, which will be our text. Again, you can just copy the same thing here. When we can also see it when we print our results, when we run the program here again. Then I'm going to show you like how are these indices or like these indexes act like working. So now we have everything. Now we can just read in our image again here with OpenCV and then display it together with the rectangle and also the text of what we have detected. So here we're just going to create an image which we set equal to cv2.imread, and then we're just going to read in the image here as we did up at the top. So we're just going to copy this path here. We're going to have imread, specify the path that we read in. So now we have this one here. Now we can draw a rectangle on our image. So we have image equal to cv2.rectangle. Rectangle here, we just pass in our image first of all. Then we have our top left corner and our bottom right corner here that we need to specify. Then we also need to specify the color. So in this example here, we're just going to go with BGR. So we have a red color for our detection. We have 0, 0, and 255. And then we also need to specify the thickness here of our bounding box or the rectangle that we want to draw around it. The last thing here that we need to put on top of our image would actually be the text. So here we can just use this put text function. We pass in the image where we want to draw our text. And also where do we actually want to draw this text here, it will be the top left corner. So now we both have our, here we can see that we need to specify the text that we want to write on our image. So that will just be our text, and then we need to specify here the org, which will actually be where in the image do we want to draw this text. So that will be over here. So it will be the top left corner. So we're basically just going to draw it or like display this text here on the top left corner on top of our bounding box. Then we also need to specify our font. We just go inside here. We just take some font here from OpenCV. We're just going to go with the simplex font. Then we also need to specify the font scale, so the size of our text. And then we need to specify the color. Again, we're just going to go with the same color as our bounding box. And then here we can specify the thickness. So we have a comma here, and then we have the thickness. And then we also need to specify the line type. So that will just be cv2.line. And then we're just going to use line_AA. So these are just some default things here that we need to set up. So now we both have reading in our image. We're drawing a rectangle, which is the bounding box on top of the text that we're detecting. And then we're just going to put the text here. So this will be the zeroth detection. So we're only going to show one detection. As you saw, we actually have several detections. We had like I think it's 4 detections in our image, but we're just going to take the 0th element because then it will be the Python detection in our image. In just a second, after we've seen the result, I'm going to show you how we can actually display all the results, how we can filter out the false positives and so on, where we just have a for loop running through all these detections here, and then we're going to draw it on the images based on the threshold or the confidence score that we can set up. So here we can actually just use imshow to show what we have actually detected in our image. So we're going to use imshow. We're just going to call it im, and then we're going to display the image that we just created up here. We will just have a wait key here so we can actually see, and it won't terminate the program immediately. So we can actually see what is going on and see the results on our image. So now we're going to run the program. Again, we will have the outputs here. So now we pass our image through the model. It will print out the outputs again, and now we'll actually display the image with our Python detection. So here we can see an example of our image or like a character recognition with EasyOCR. So we have the thumbnail here, Python versus C++ in computer vision. So now we can see the first detection is this Python up here at the top left corner. We're drawing a red bounding box around a Python or our text detection. And then we also display what we have actually detected. So we have detected Python up here at the top left corner. So this will be the first detection in our image. We also saw that we're detecting versus, and we're also detecting computer vision, and also this VS down here at the bottom. So we have this thumbnail here where we can detect the text in different kind of like the different kind of areas. It is really good. We have a confidence score of almost like 100%. It's 97% confidence score that is actually like Python that is detecting. So this is actually like a really nice model, and you can also see like how fast it actually did these detections on the image. But that is because we're running the program or like the model on the GPU. So if you're running it on the CPU, you will actually like have it will be way slower. So you should definitely just go for the GPU if you have that. And you have set it up with CUDA. So now we're going to take another image where we're going to take all the detections that we have in our image. This will be an image of several the different types of license plates. So if you want to do license plate recognition and stuff like that, you can also use EasyOCR for that. As I'm going to show you, we're just going to have an image and then we're going to display all the detections that we have of these license plates in the image. So here we're just going to read in a new image. We can actually just go up and copy paste this one up here at the top. We're just going to copy this line of code, and then we're going to read in a new image. So this will be called, I think it's called license plate, and it will be a JPEG. So now we have the image written here. Then we can actually go in here and just pass our image through our OCR results again. So basically we're just going to do the same thing. We have our reader up here, but now we have a different OCR results where we just need to pass in our new image instead. So we're just going to take this path, copy paste it in here, and now we'll get the new results with our license plates detection. So now we're going to go down here at the start. We're just going to print out the results here again so we can see what is going on. So we have our OCR results. I'm copying pasting it. And now we can go down here and actually set up some confidence score threshold so we can filter out the low detections or detections that we're not sure or confident about. So here we're going to set up our confidence threshold, and we're going to set it equal to 0.2. So if we're more confident than 20% that this is actually text that we're detecting in the image, then we want to display it, and then we can always play around with this parameter here if we get a lot of false positives when we're running our program. So basically now we have to do the same thing. We just have a for loop running through all our detections. So we have 4 detection in OCR results. So we're just going to run through all the OCR results that we have because we know all the indexes. So the 0th index will be this the 0th detection and so on, or the first detections and so on. So we just have this for loop running through all our OCR results. Then we can go inside if detection. So we just go inside each of the detections. And if the second element here in the detections, which will be the confidence score, if that number is greater than our confidence threshold, then we will actually do something. We will draw our detection, we'll draw the bounding box, we'll draw the text on top of our image so we can display it later on. So this is actually the filtering I've been talking about throughout this video, where we're reducing the false positives in our image. Again, if you still have false positives, you should just increase this value here of our confidence threshold. So you could maybe go up to 50% if we're more confident than 50% that this is actually a correct detection, then we use that as a detection. So here we're just going to take our top left corner. So our top left here will be equal to, we're just going to create a list here with the values. So we're going to take all the values in all the detections here when we run them through this for loop. So we're going to take the integer of our value here, and then we just go have another for loop where we're running through all the values in our detection. So here we have value in detection. So we have our detection. We know the 0th element here inside of our detection will be the top left corner. So this will be the exact same thing as these 2 indexes. The first index here will be our detection in our for loop running through our OCR results. And then these 2 indexes here in our tuple would actually be our top left corner. So we're going to run through all the top left corners in our detection. So all the results that we have, if we're actually sure that this is the text that we want, then we just take all the top left values for those detections. We're going to do the exact same thing for the bottom right corner, so we can actually draw our bounding box. So this will be our bottom right. Then we take the integer of the value here again, and now we take the second element here, so we get all the bottom right corners. Then we also need all the different kind of text in our image, so we're going to have this detection text equal to detection. I misspelled detection up at the start, I can see. Detection, I'll just copy paste it. Detection, and then we're just going to take the first element here of detection, which we know is our text, and then we can actually just have our images. We're just going to copy paste these 2 lines of code, and then we can just have our for loop running through all our detections and then displaying all our detections on these images here that we can then display at the end. So this will be our license plate image. So we're just overriding this variable up here. So we're just overriding our im variable. So we're going to do the exact same thing. We just pass in our image. We're going to just pass in our top left corners, the bottom right corners, and we're going to do the exact same thing down here at the bottom. So now we actually have all the detections. We're running through our whole image. We pass our image through our EasyOCR model, EasyOCR model. We get the results out. Then we just run through all the results, index them so we can get our boundary box, the text, and also filter them based on our confidence score. So this is everything you need. Again, you can follow along, do the exact same thing, or just go into my GitHub, take the code, pass your own images through, and so on, and try to see if you can recognize some numbers, text, and so on in different kind of images that you have on your own. You can also try some handwritten text or digits or something like that, and see if it can actually if it's actually able to do recognition of handwritten digits and letters as well. So here we have OpenCV. We just go in, use imshow again. So actually, I'll just copy paste the code up here. So we're just going to do the exact thing, takes exact same thing. We have overwritten the image. So now we can just do the exact same thing and have a wait key here 0. So we'll just wait until we hit a key on our keyboard on top of our image, and then it will terminate the program. So now we can run the program here again. It will run the first couple of lines of code here up at the top, where it loads in the thumbnails, dot detection with Python, and so on. But now we're passing through both images. So again, we have already seen these results. So I'll just hit an arbitrary key on our keyboard. So we go to the next lines of code that we've just written with our for loop. So this will actually be the detections that we now get with our license plate. So we still have this confidence score of 0.5, so it needs to be above this confidence score here. So we actually say that this is correct or like a valid detection. So down here we can see all the detections here that we do, and now we're not even like printing all of them, but we can see all the license plates here. We're detecting both like the number and also the state here, and also some other different kind of stuff. So we have Colorado, we have the numbers, we also have like GHT430. Sometimes it actually splits it up, so first it takes the numbers here and then it detects the text here at the end, but it actually it is separated here. But up here at the top we can see that it just detects this as a space. So there is some false positives and so on. You should actually you can try to do some post-processing and so on to make it easier. You can crop out some regions if you know where your license plate is in the image. You can try to crop out that region, and just pass that region through your OCR model and so on. So you can do a lot of different kind of things. But again, you can see all the results here at the bottom. We can see we get some confidence scores below 50. We have one here at 25. We also have some other ones up here. I just saw one like 0.03. I also saw one like 0.20 here, 0.16, and so on. So if you actually load this threshold here and run through the program again, we should get more detections in our images, or like in our image, for our different license plates that we have. So here we'll just pass in our image through again. I hit an arbitrary key, and now we can see that we get way more detections on our image here. So now we can actually see that we're detecting all the numbers here in our license plates. Before we couldn't actually detect some of these numbers here in the license plates, maybe because it was just like a couple of numbers, like a couple of scores under our threshold value and so on. But now we can actually see we have a really nice detections of all these different things. We even detect like some text here, even though it's really blurry even for me. We still miss some text here up here at the top. We're still detecting Colorado. We're missing Michigan here and so on. So this is actually like really nice. You can do some more logic for filtering and post-processing these results here from EasyOCR. But just we need a couple lines of code. If you just want one detection, you can just go in, index them. If you want all the detections, we just have this for loop here running through all the indexes and then displayed on our image. So this is really easy to set up. It's just a couple lines of code, and it can be used for a lot of different kind of things. It can be used for like text recognition, like play recognition. It can be used for a lot of in real life projects and so on. So thank you guys for watching this video here, and remember the subscribe button and bell notification under the video here. It just really helps me and the YouTube channel out in a massive way. And also like this video here if you like the content and you want more similar stuff about this here in the future. We can also do some other different kind of projects with plate recognition. We can try to like take the car, try to extract the license plate of that car, and then pass that through the EasyOCR model. So again, like the video if you want videos about those things here more in the future. I'm currently also doing this computer vision tutorial where we're just talking about basic image operations, camera calibration, stereo vision, how we can get depth information in our images, combine that to point clouds, do a lot of different kind of So that is a really nice tutorial, and you should definitely check it out if you're into that. I'll link to it up here, or else, and I'll see you next week, guys. Bye for now.